France ready for 100% jet engine transfer to India for 5th-Gen AMCA a year after GE deal for LCA Techus. Indian ambassador to France, George Ashraf, said Safran was willing to transfer technology. Ashraf was addressing the media on January 26 during the state visit of French President Emmanuel Macron to India to join the annual Republic Day parade in New Delhi. India and France are already discussing the cooperation between Safran and India's Defence Research and Development Organisation. In July 2023, during Indian Prime Minister Narendra Modi's official visit to Paris, the two nations announced that a roadmap for the joint development project for a combat jet engine would be prepared by the end of that year. Still, no formal announcement of the roadmap has been made. Ashraf said the primary focus of the deliberations at present was to align the engine specifications with India's future fighter jet requirements. He said India was looking for a comprehensive approach to tech transfer beyond just the transfer of manufacturing technology. The deal aims to delve into the actual design phase, metallurgical aspects, and other critical elements that contribute to developing advanced jet engines. Ashraf acknowledged the negotiations on the deal were complex, and navigating the complexities required finding common ground to meet India's overall military requirement targets. Safran, a key player in the aerospace industry, is willing to engage with the Indian Military Research Agency across various phases of the Advanced Medium Combat Aircraft (AMCA) project, including design development, certification, and production. When the negotiations conclude, and the deal between the French firm and the Indian side is concluded, this would mark the second such arrangement India has entered into recently to meet its unfulfilled need for a jet engine for its indigenous combat aircraft projects. Safran for AMCA, GE for Techus Mk2. In June 2022, during Modi's official visit to the United States, American jet engine maker General Electric announced in a media statement that GE Aerospace has signed a Memorandum of Understanding, MOU, with Hindustan Aeronautics Limited, HAL, to produce fighter jet engines for the Indian Air Force. In addition to potentially generating new work in India, the GE agreement would help several US facilities that currently support work on the F414 engine with additional volume. As a result, GE said then, while the Safran deal in the future would meet India's jet engine requirement for its futuristic twin-engine AMCA project, the agreement with GE would see another futuristic combat aircraft's powering needs, in this case, the Techus Light Combat Aircraft's Mk2 variant. India has already decided that its Techus LCA Mk2 aircraft would be fitted with the GE F414 jet engine, and so would its LCA Mk1A, of which the HAL would produce 180 aircraft in Bangalore. The GE F404 jet engines power the LCA Mk1 jets, 40 already inducted into the Indian Air Force and are operationally deployed in 2 squadrons. The agreement with GE includes the potential joint production of F414 engines in India. 8 F414 engines have been delivered as part of an ongoing development program for LCA Mk2. The latest agreement will advance GE Aerospace's earlier commitment to build 99 engines for the Indian Air Force as part of the LCA Mk2 program. GE began working with the Aeronautical Development Agency and HAL to support the development of India's Light Combat Aircraft, LCA, with F404 engines in 1986. Subsequently, GE Aerospace's F404 and F414 have been part of the development and production programs of LCA Mk1 and LCA Mk2. GE has delivered 75 F404 engines. Another 99 are on order for LCA Mk1A. India's tryst with jet engine technology. Jet engine technology is one of the significant gaps in India's DRDO's capabilities, as its successive efforts have failed to produce an adequately powered jet engine. The present effort, jointly with Safran, would be called the 5th-Gen project when it fructifies. In its previous effort, beginning in 1986, India had attempted to develop a jet engine from scratch using turbofan technology, calling the project Kaveri, under the Gas Turbine Research Establishment, GTRE, of the DRDO. A turbofan power plant should enable adequate thrust for the aircraft to achieve atmospheric glide and supermaneuverability. File image, GE 414 Aero engine. The Kaveri project, with $53 million in funding, was part of the Techus Combat Jet project. Though the plan was for 17 prototypes of Kaveri engines, the first bid could only achieve the core module, called Cabiny. The third prototype was the first to get variable inlet guide vanes on the first 3 compressor stages and had its first run in 1995. In 1996, the first entire run of the Kaveri engine took place, and all 5 ground test prototypes were tested in 1998. The initial flight tests were planned for 1999, and the test on Techus was to happen in 2000. However, the sanctions that came following the 1998 Pokhran nuclear tests resulted in the Kaveri project slowing down due to technology acquisition difficulties. The Kaveri project continued in spurts till mid-2004 when a failure during a high-altitude test in Russia ended all hopes for the engine to get on board the Techus aircraft. By then, the Kaveri engine had done 1,700 hours of tests. The Kaveri engine was sent to Russia again in 2008 for its second high-altitude test, though in 2007, GTRE decided to bifurcate the project into two separate programs. The K9 Plus program was a proof of concept in complete design and for experience in integration and flight trials, and the K10 program was the final production variant through foreign collaboration. After various trials and tribulations, in 2016, India announced a collaboration with Safran to make Kaveri engines worthy of the Tekes fighter jet. However, the plan has now shifted to get Kaveri ready to power India's indigenous unmanned combat aerial vehicles in the future.